All right, so today we're going to talk about how to solve a triangle sides and angles using tangent. So first we're going to start off with this warm-up. If I've got this fraction equals this fraction, the thing we need to do is I see, okay, I've got 2 on the bottom here, 4 on the bottom here. I can multiply both sides by 2 and both sides by 4. And if you think of it this way, the 2 is going to cancel out with that, and the 4 is going to cancel out with that, and then we end up with 4 times x is equal to 2 times 8 plus x. Another way to think of this is cross-multiplying this, and then you get 4 times x equals 2 times parentheses 8 plus x. All right. Then the next thing we're going to do is we're going to do distributive property with the 2, and then we end up with 2 times 8, which is 16, and 2 times x, which is 2x. And then the next step is I want to subtract 2x on both sides to make the 2x minus 2x, make that go away. And then I got 4x minus 2x gives me 2x. 2x equals 16. Divide both sides by 2, and you get x equals 8. Okay, so now we're going to talk about tangent. You might want to hit pause if you need more time to copy this down. All right, so there's a tangent ratio. Now, you can get it, depending on where your angle is going to determine which side is opposite. So if the reference angle is here, then this side right here is going to be called the opposite because it's far away. Now, if my reference angle is up here, this side is going to be the opposite because it's far away from the reference angle. On the problems you're going to get for homework, they're going to tell you which one's the reference angle. Now, the side touching the reference angle is called adjacent. And the side touching the reference angle over here is called adjacent. So you need to think of it as opposite is far away and adjacent is touching. Okay. So the ratio of opposite side and adjacent can be converted into decimal. And this relationship will always, there is a relationship between the angle and the decimal. So let's solve for this missing side here. So whenever I have an angle 20 degrees, then I can go to my tangent table and I could say, okay, at 20 degrees, my ratio is going to be 0.364. So then I can start solving this. I can say, all right, so we can say tangent 20 degrees. And remember, this is equal to opposite over adjacent. So the opposite side is x, and the adjacent side touching is 5. Okay, and as I mentioned a minute ago, tangent of 20 degrees, the decimal value is 0.364. So I'm going to replace that with 0.364. Okay, now this is equal to, as we just said, x over 5, right? Okay, so now we can solve for x. I like to put this over 1, and then just like in our warm-up, we can cross-multiply, and we've got 1 times x is equal to this decimal times 5. So 0.364 times 5. Now, do I really need to put 1 times x? No, because 1 times x is x, of course. So what is this decimal times 5? Okay, so 5 times 0.364 is going to give me 1.82. Okay, and so this is the length of the side of x. Okay, let's do another example. You might want to hit pause and think about this or replay this question to get to hear it again. Okay, here's another problem. Once again, opposite side is far from the angle. Okay, adjacent is touching. Okay, so I'm going to write this as tangent 35 equals the opposite, which is 7.1, divided by x. As we said, it's opposite over the adjacent. Okay, well, that's hard to see, but that's an x. Okay, so right in black. Okay, so now I'm going to take out my table, and I'm going to say 35 degrees, right? So 35 degrees, when the angle's 35 degrees, my ratio is 0.7. So I'm going to substitute or replace tangent 35 with 0.7. Okay, and then now I've got that equal to this ratio of 7.1 over x. And just like we did on the other problem, I could put this, oops, why did I put that over 1? It's over x, right? I could put this over 1 and cross multiply, right? And then I would get 0.7x equals 1 times 7.1. So 0.7x equals 7.1. Now, how do I solve for x? Well, in order to solve for x, I need to divide both sides by 0.7. So now I'm going to divide both sides by 0.7. And by doing that, that's going to make that cancel out. And so now I've got x equals 7.1 divided by 0.7 is going to give me 10.1. 10.1 is the length. Okay. Let's do another example. We're going to do something called inverse. Okay. Now, inverse tangent is when you're given the ratio and you want to find the angle. So, once again, since this is my reference angle, the 6 is going to be opposite, and the one touching it is going to be adjacent. Okay, and as we mentioned before, tangent of the angle, so I'm going to call it x, is the angle, is equal to opposite over adjacent, so 6 over 4.3. So I can use my calculator to do 6 divided by 4.3. And I get this decimal, 1.395. So I can say tangent x equals 1.395. And then I can go to my table, and whenever I get close to 1.395, that's pretty close to this. This is 1.37, and this is 1.42. So I'm going to call that, so this is 1.37, 1.395. So I'm going to say that x is equal to 54 degrees. Okay. Now you can do this on the calculator. If I had 1.35, so on the earlier one, like here, if I typed in if I pushed the tangent button, and on this problem here, if I typed in 35 and hit enter, it's going to tell me this decimal is 0.7. So if I don't have the table, I can use my calculator to get this value. Now, in this kind of situation, if I'm given the ratio and I want to find the angle, I have to do something called inverse tangent. So I hit second tangent, and I get this tan with the -1. And I'm going to type in the decimal, 1.395, and then I hit enter, and I get the angle, as you can see, is 54.3 degrees. Okay. All right. You might want to hit pause and rewatch this video. Okay. Let's do one more. Okay. So if I've got here, my opposite side is this value. My adjacent side is 7. So I'm going to say tangent x equals opposite over adjacent, so 4.2 divided by 7. I can type that into my calculator. 4.2 divided by 7 gives me 0.6. So I have tangent x equals 0.6. And if I want to write this as an inverse into my calculator, I would write this as tangent with a -1 like that, 0.6. And that's going to give me the missing angle x. And so I can find it two ways. I can look at the table, and when is the table, when is the ratio 0.6? I would say that's pretty close. 0.6, it's going to be 31 degrees. So that means angle x is going to be equal to 31 degrees. Okay. Now the other way I could do it on a calculator is I could say second tangent and put the decimal 0.6, and then I hit enter, and once again I get 30 degrees. You may want to watch this video again if you need extra help. Okay, so the important thing to note, whenever the opposite side is smaller than the adjacent side, then your angle, the reference angle here, is going to be smaller. Okay, this angle here is going to be smaller than 45 degrees. Now, whenever the opposite side and the adjacent side are exactly the same length from the reference angle, then it will be a 45-degree angle always. Okay. And then lastly, whenever this one here is taller than this one here, then it's going to be a much bigger angle than 45 degrees. Okay, that is your notes, and good luck with your homework and classwork.